Hello everyone. Now coming to the GPRS architecture, we are going to study each and every functional components of GPRS and what are the new additional components and mm, what are its functionality in order to provide data along with voice communication. So here we will, as I said, that the GPRS uses the existing infrastructure or existing functionality of GSM in order to provide both voice and data communication. So few existing system of GSM has to be upgraded in order to support the GPRS service. As we all know that in order to support 4G services, we had to change our phone. We cannot use the same terminal or mobile agent in order to get 4G services. We have to have a smartphone in place. We cannot use keypad phones in order to communicate with VoLTE, voice over LTE, that is. Similarly, here also the GSM MS needs to be upgraded in order to support the GPRS service. Similarly, as we know, BTS software packages also need to be updated. Those applications also need to have support for GPRS. Here, I will tell you the chronology, how it works, how a call is made, initiated, how it travels, and how the entire communication takes place between one mobile system to another mobile system. So, here, once a call is initiated, or a request we can say, because it may not be a call, it may be a data request, it may be a voice request. So going with that perspective, if a request is made, it is channeled through the BTS, as we know that MS and BTS are connected through the or air interfaces. So after after the arrival of the request to the BTS does the access part, that is how to access the channel, what bandwidth to use, what are the multiplexing, what kind of multiplexings need to be used here. And after that, once the BSC come into play, which is the junction to decide whether it's a data request or a voice request. So the BSC, the base station controller here, decides, or by analyzing the nature of the packet, it has to route the packet or it has to transmit to the mobile switching controller or to PCU, the packet control unit. If it's a data message, it has to route through the packet control unit. If it's a voice request, it will use the GSM architecture entirely that we had studied earlier. So here what will happen? I am taking the later case. If it's a data packet or a data request, then the PCU uses the FRI interface in order to transfer the data to the GPRS network. Now what is a GPRS network? Of course, this entire network is GPRS network. But here are the additional component to the existing GSM network which makes possible the data connection. So the two most important nodes added or components added we can see is serving GPRS support node SGSN and gateway GPRS support node, that is GGSN. So after going through all this, the packet is ultimately transferred to the data network. Now, what is the actual functionality of SGSN and GGSN? SGSN is responsible for mostly authentication of GPRS mobile, number one, registration of mobiles in the network, number two, and thirdly, mobility management and collection of information on charging. It makes it possible that it gets the packet and it has to do most of the important work. That is, it has to authenticate whether it is a valid request or not. Second, it has to register the mobile for the network. The registration of mobile system in the GPRS network is done by SSGN, and it has to do the mobility management. How it does the mobility management? Because it is connected to the HLR, VLR and AUCS, as you can see. The mobile switching controller takes on the responsibility of a large area, as I said earlier during the GSM architecture video. It has to maintain a lot of database to carry out its work. What are the subscribers? What are the users? What is the current location of the user? Whether they are protected or not, whether the communication is being encrypted, whether it maintains confidentiality or not, everything is done through these database information. So SGSN, as you can see, also interacts with HLR, VLR, AUC. HLR as in the home location register, which contains all the user details, and VLR, which is the visitors location registers. It consists all the users who are on roaming, who have come to other locations. They are not present in their home location. And authentication center is, of course, for security. So SGSN communicates with all of this to do its job. Next is GGSN. Now this acts like a gateway. In communication, we know the role of a router. The router majorly decides where to route the packet. For that matter, it maintains a lot of things, a lot of information like the routing table, the interface addresses, the shortest path, all of this. In a CRISP, GGSN acts as an interface and a router for GPRS network. It connects the entire rest of the network with the data network, which is of course the job of an interface. Secondly, it routes the packet. It has to route it to the proper tunnel or proper channel. So it acts as an interface and a router to the external network. It contains routing information for GPRS mobile, which is used to tunnel packets through the IP-based internal backbone to the correct serving GPRS support node. So this was all. I think every component has been explained fully right now. I also have shared the MC PDF with all of you. All the contents, the entire syllabus course content has been given to you. You can go through that. If you have any doubt, feel free to ask me in my classroom. You can post the comments, you can ask doubt, you can share your thoughts on this. And lastly, if you have any confusion regarding GPRS, I will also post some of the useful links which will make you understand GPRS the easiest way possible. So that will be all for now. This is Shashwati Das signing off.